National Electrical Code, often called the NEC, provides guidelines for the maximum number of outlets permitted on a single circuit within a single family dwelling. Specifically, the NEC states that a 15-amp circuit can support a maximum of 15 outlets, while a 20-amp circuit can handle up to 18 outlets. These limits apply to both lighting outlets and receptacle outlets. These regulations exist to ensure the electrical system operates safely and efficiently. Overloading a circuit can lead to tripped circuit breakers or blown fuses, and in more severe cases, it can cause electrical fires. Each circuit is designed to manage a specific electrical load, and exceeding this load can create hazardous conditions. The NEC outlines these limits to prevent such overloads and maintain electrical safety. There are a few exceptions to the general rules about outlet limits per circuit. Firstly, dedicated circuits are exempt. A dedicated circuit serves only one appliance or device, such as a refrigerator, washing machine, or air conditioner. Because these appliances typically require a significant amount of power, they are placed on their own circuits to prevent overloading other circuits in the home. Secondly, ground fault circuit interrupter, often called GFCI, outlets can sometimes have a higher number of outlets per circuit than the standard limits. The allowable number of outlets on a GFCI protected circuit depends on the rating of the GFCI device itself. It is essential to consult the manufacturer's specifications to determine the maximum number of outlets for a particular GFCI. While the NEC permits up to 13 outlets on a 15-amp circuit and 18 outlets on a 20-amp circuit, many electricians recommend a more conservative approach. It is generally advisable to limit the number of outlets on a single circuit to between 8 and 10. This practice reduces the risk of overloading the circuit and provides a greater margin of safety. Limiting the number of outlets helps to ensure that the circuit breaker will not trip frequently and that the wiring will not overheat. When determining the appropriate number of outlets for a circuit, it is crucial to consider the types of devices that will be plugged into those outlets. High-power devices such as hair dryers, space heaters, and power tools can draw a significant amount of current and quickly overload a circuit. If you anticipate using multiple high-power devices on a single circuit, it is best to reduce the number of outlets on that circuit or to use multiple circuits. In addition to limiting the number of outlets per circuit, it is also essential to use the correct wire gauge for the circuit. The NEC specifies the minimum wire gauge required for different circuit amperages. Using a wire gauge that is too small can cause the wire to overheat and create a fire hazard. It is always best to err on the side of caution and use a larger wire gauge than required. Regularly inspect your electrical system for any signs of problems such as flickering lights, warm outlets, or tripped circuit breakers. These can be indications of an overloaded circuit or other electrical issue. If you notice any of these problems, consult a qualified electrician to have the system inspected and repaired. It's also important to consider the cumulative load on a circuit, not just the number of outlets. Even if you have fewer than the maximum allowed outlets, the circuit can still be overloaded if the devices plugged into those outlets draw too much current. To calculate the total load on a circuit, add up the wattage of all the devices that will be plugged into the outlets on that circuit. Then, divide the total wattage by the voltage of the circuit, which is typically 120 volts in a residential setting, to determine the current in amps. The calculated current should not exceed the amperage rating of the circuit breaker or fuse protecting the circuit. The NEC provides detailed guidelines for electrical installations, covering various aspects such as wiring methods, overcurrent protection, grounding, and equipment installation. Adhering to these guidelines is crucial for ensuring the safety and reliability of electrical systems. The NEC is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. It is important to stay up to date with the latest version of the NEC to ensure that your electrical installations comply with current standards. Many local jurisdictions adopt the NEC as the basis for their electrical codes. However, some jurisdictions may also have additional requirements or amendments to the NEC. It is important to check with your local building department to determine the specific electrical codes that apply in your area. Proper electrical installation requires specialized knowledge and skills. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. A qualified electrician will have the necessary training and experience to ensure that the electrical installation is done safely and in accordance with the applicable codes. When hiring an electrician, check their credentials and make sure they are licensed and insured. Ask for references and review their past work to ensure they have a good reputation. A qualified electrician will be able to assess your electrical needs, recommend the appropriate solutions, and perform the work to a high standard. Regularly testing ground fault circuit interrupters, often called GFCIs, is an important part of maintaining electrical safety in your home. GFCIs are designed to protect against electrical shock by quickly interrupting the flow of electricity if a ground fault is detected. Test GFCIs monthly by pressing the test button on the device. The GFCI should trip, cutting off power to the circuit. If the GFCI does not trip, it may be faulty and should be replaced. Consider using arc fault circuit interrupters, often called ASIs, in your home. ASIs are designed to protect against electrical fires by detecting arc faults, which are dangerous electrical conditions that can cause fires. ASIs are typically installed in bedrooms and other areas where people sleep. If you are renovating or remodeling your home, consider upgrading your electrical system to meet your current and future needs. This may involve adding new circuits, upgrading the service panel, or installing new outlets and lighting fixtures. Consult with a qualified electrician to determine the best way to upgrade your electrical system. Over time, electrical systems can deteriorate due to age, wear and tear, and environmental factors. Regularly inspect your electrical system for any signs of deterioration, such as cracked or frayed wires, loose connections, or corroded components. If you notice any deterioration, have the system inspected and repaired by a qualified electrician. Proper grounding is essential for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock. Ensure that your electrical system is properly grounded and that all grounding connections are secure. Surge protection devices, often called SPD, can help protect your electronic equipment from damage caused by power surges. Power surges can be caused by lightning strikes, utility switching, or other electrical disturbances. SPD are typically installed at the service panel or at individual outlets. In addition to following the NEC guidelines for the number of outlets per circuit, it is also important to use energy-efficient lighting and appliances. Energy-efficient products can help reduce your energy consumption and save you money on your electricity bills. Look for the Energy Star label when purchasing new lighting and appliances. Consider using a whole house surge protector to protect all of your electrical equipment from power surges. A whole house surge protector is installed at the service panel and provides protection for all circuits in your home. In addition to the NEC guidelines and recommendations, it is also important to follow any local regulations or requirements that may apply to electrical installations in your area. Check with your local building department to determine the specific electrical codes that apply in your area. When working with electricity, always follow safe work practices. Turn off the power to the circuit before working on any electrical components. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Do not overload extension cords or power strips. Extension cords and power strips are designed to provide temporary power to devices that are located far from an outlet. However, they are not designed to handle high-power devices or to be used as a permanent wiring solution. Overloading extension cords or power strips can cause them to overheat and create a fire hazard. When using extension cords, make sure they are properly sized for the intended use. Use heavy-duty extension cords for high-power devices and avoid using multiple extension cords plugged into each other. Replace any damaged or worn extension cords immediately. Never run extension cords under rugs or furniture, as this can trap heat and create a fire hazard. Avoid using power strips with built-in surge protectors, as they may not provide adequate protection against power surges. Use a separate surge protector for sensitive electronic equipment. If you are planning to install new electrical wiring or make significant changes to your existing electrical system, obtain the necessary permits from your local building department. Permits ensure that the work is inspected and complies with the applicable codes. When selling your home, disclose any known electrical issues to the buyer. This includes any problems with the wiring, outlets, circuit breakers, or other electrical components. Disclosing electrical issues can help avoid potential legal problems down the road. If you are buying a home, have the electrical system inspected by a qualified electrician before closing the deal. An electrical inspection can identify any hidden problems that may not be apparent during a visual inspection. Consider installing tamper-resistant receptacles, often called TRR, in your home, especially if you have young children. TRR are designed to prevent children from inserting objects into the outlets and getting shocked. Replace any old or worn-out outlets with new ones. Outlets can become loose or damaged over time, which can create a fire hazard. When replacing outlets, use the correct type of outlet for the location. For example, use a GFCI outlet in bathrooms and kitchens. Avoid using aluminum wiring in your home. Aluminum wiring was commonly used in homes built in the 1960s and 1970s, but it is now known to be a fire hazard. If your home has aluminum wiring, have it inspected by a qualified electrician and consider replacing it with copper wiring. Keep electrical panels and equipment clear of obstructions. Electrical panels and equipment need to be accessible for maintenance and repairs. Do not store boxes, furniture, or other items in front of the electrical panel. Maintain a safe distance from overhead power lines. Overhead power lines can carry high voltages of electricity, and coming into contact with them can be fatal. Keep trees and shrubs trimmed away from overhead power lines. Call the utility company before digging near underground power lines. Underground power lines can be damaged by digging, which can create a safety hazard. The utility company can mark the location of underground power lines before you dig. Be aware of the signs of electrical shock. Electrical shock can cause burns, muscle spasms, and cardiac arrest. If someone is experiencing electrical shock, do not touch them directly. Turn off the power to the circuit and call emergency services immediately. Learn basic first aid for electrical shock. First aid for electrical shock includes calling emergency services, checking the person's breathing and pulse, and performing CPR if necessary. Regularly review electrical safety tips with your family. Make sure everyone in your family knows how to use electricity safely and what to do in case of an electrical emergency. The information provided in this narration is intended for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work or concerns.